Okay, so today we're going to talk about probability. We're moving to a new unit. I called it Unit 12, probability. So if you're in Canvas, that's where we're at. The first thing we're going to talk about is Venn diagrams. Venn diagrams, you've probably seen them in science a lot, right? So they show the relationship between 2, 3, or more variables. So, yeah, comparison, right? So inside, right, you might have like baseball. Oh, I should probably get something to write with. Baseball and math. I don't know. I'm just making something up, right? So like how many people play baseball and like math, right? I don't know, right? So and then there's numbers in here, and then there's usually like a number out here. There's like 15 out here, and then like 5 and maybe 2, and then like 2, right? So, right. No, there's 15 people. No. The number out here doesn't have to, that's not what it adds up to. The number out here means you don't like baseball or math. Okay? The number in here means people only like baseball, only math and baseball. And then the number out here is neither of those. Okay? Does that make sense? So there is a number out here that means neither. Okay, same with the 3, only you compare 3 things together, right? Okay, so we're going to answer a few questions and see how we do. So I'm going to do the first one, I'm going to do the 2 one, and you guys have to do the 3 one. I know, I'm so mean, right? So how many students are in band? How many students are in band?
225.
No. How many students are in band, you guys?
350.
No. I'm going to look at my band circle. Oh, hold on. Let me let somebody in, and then we'll talk about it.
225.
What did you say? Sorry, Zoe, I didn't hear you.
No, I just answered to the question you asked.
Yeah, I didn't hear your answer, sweetheart.
Oh, I said 225.
Not quite. So,
Oh.
so I'm going to look. So the band circle is this circle, right? This whole circle. So how many people are in band?
Oh, 275.
275.
Because you have to add the 50.
Because I have to add the 50. Okay, does that make sense, Zoe? So everybody in that circle is in band. And then the next question says how many students are only in band? Now how many people are only in band? 225. Does that make sense?
Makes a lot more sense.
Okay, and then how many students are both in band and choir? 50. That's where this one comes in. This area right here comes in. They're both in band and choir. And how many students are in neither band nor choir? 375.
That first one got me so confused. You're
Yeah.
Like, how many students are in band? You're like,
Yeah, you got to add them together. You got to add the whole circle together. Okay? Now the difference is this only in band. There are 225 that are only in band, but then there's 50 that are in band and choir, so I have to add that in there. Is that okay?
Yeah.
Zoe, did that make sense?
Yeah.
Okay, awesome. Jonathan Medina. Oops. Okay, so now I want you guys to just take a few seconds and see if you can answer these. So how many students are taking a foreign language?
530.
530 students. Very good. I'm going to change my color. 530 students. So if I take my circle, my foreign language circle here, I'm going to add everything that's in that circle because those are all the kids that are taking a foreign language, right? So then it says how many students are in music and art. So what?
1,095.
Huh?
1,095.
Nope.
Wait, so music?
So it just says music and art. So the circle, the part that overlaps, this is how I think about it. So the part that overlaps just music and art is this part right here. Here's music, here's art. Those are the kids that are taking music and art right there. How many is that?
Music and art.
Yeah, it doesn't say music, art, and foreign language. It says music and art. So how many students is that?
Because I added 450 to.
Yeah, but the 450 are only taking music. They're not taking art.
So it would be 145.
145, yes. How many students? Does that make sense? Yeah, 145. There you go, 145. So I wouldn't add the 95 in there because that's music, art, and foreign language.
Oh, okay.
So this one is only 145.
So the 95 and 125 is that like both or all three?
What?
Wait, so the last where it says 80, so that would be foreign language and art,
Yes.
and then okay.
Yes, because that's where the circles overlap, right? Does that make sense?
Yeah.
Okay. And then the next one says how many students are not in art. So this is how I figured this out. I circled my art circle. And I added up all the numbers that are not in that number, right? So this number, 450, 125, 230. And that added up to, I think you got it right. Zoe, you got it right. And it should have been 805.
Yes, sir.
And then the students not in music, I did the same thing with music. I circled my music circle here. And I added up everybody that wasn't in music. So this one, and this one. And got 510, I think.
512.
It's 510.
Check. I think I
230 and 280. 510. Okay, and now the next one says how many students are in music, art, and foreign language. So how many has all three of them? Well, there's only one area on here that has all three, and that's the very middle part, which is what? 95.
What? Oh my god.
It's the same as the other one, right?
Okay.
I don't want the ones that just are in music or just in music and language arts. I want them in music, foreign language, and art.
So when it says music, art, and foreign language, that would be
Only the very middle piece where all three circles overlap.
okay. But what's 125 though?
125, that's music and foreign language.
So music and foreign language. 80 would be foreign and art.
Yes.
And then 90 would be all. 95 for all three.
Yes, because that's where all three circles overlap. Does that make sense now? Okay. And then how many total students are represented?
1,325.
1,325. 1,325. That's where you just add everybody together.
Dang.
Hello, Miss Gambo.
Good morning, Alex. Is that good? Does that make sense now? Are you okay? Zoe, I think you figured that one out. Okay, awesome. Okay, so we're going to come back to Venn diagrams again tomorrow. Okay, and do some more Venn diagram stuff. But before we do that, we need to do some probability stuff. So that's where we're going to go today is probability. Okay, so if we flip your page over and go to the next page, we're going to talk about probability for a minute. Okay, so the chances or probability of something happen can be described as a fraction or a percentage. Okay, so I can write it as a fraction, a percentage, or a decimal. I guess we should say that. And the probability of A happening is represented by P of A. Okay, and that equals the event, right? The event I want, event happening. Like say I'm drawing, like the first example, I'm drawing marbles, like what I want drawn, like blue marbles or whatever's happening. Over total number of chances. So what's my total number of marbles I have, or total number of dice I have, or total number of, you write, what's my total number of things that I have that I'm dealing with? Does that make sense? Okay. So if we talk about number one, it says in a bag there are 4 red marbles, 7 green marbles, and 2 blue marbles. If we reach in and take out one marble, what are the chances it will be, right? And we're going to write them each as a fraction, as a decimal, and as a percent. Okay, so we're going to write one of each. Okay, so I better get my calculator out. Okay. So, how many total marbles do I have?
Total marbles?
Yep.
Yeah. 13.
I have 13 total marbles, right? I have 7, 4, and 2. So I have 7 plus 4 plus 2 is 13 total marbles. Okay, is everyone okay with that? And then how many red marbles do I have?
You have 2.
I have 2.
4.
4. So the chance of getting a red marble is 4 out of 13. If I could simplify that fraction. I can't. So I can write it as a fraction, or I can write it as a decimal. And how I write it as a decimal is I take my calculator. This is super hard. Sorry, you guys, I really can't breathe today. I am so sorry. Are you okay?
Yeah.
Okay. Is 4 divided by 13. I just go in my calculator and I do 4 divided by 13 and I press enter and that's it. So I press enter and I get, and I'm going to write, I don't know how many places they're going to have you write it to in Delta Math, but I'm going to write it to 4 decimal places, I guess. I think that's what I need it. 3077. Okay? So that's as a decimal. And then as a percent, does anyone know how to change a decimal to a percent?
Decimal.
Yeah, how do I change a decimal to a percent?
Would it be? I forgot.
It's really easy. I take, you know what? No, let's just write it. Let's just write this as 2 decimal places. I'm so sorry. I want to only write this as 2 decimal places. So this should be 31. So let's write this as,
Have you recorded yet?
yeah,
Okay.
I already checked. Thanks. So it's thanks.
Finally, for the first time,
Not really.
second time.
So 0.31. And so as a decimal, how do I change a decimal to percent? Is I take my decimal and I move it to the right 2 directions, or I take my decimal and multiply it by 100. I can take my calculator and multiply by 100, or I can just take my little decimal and I can move it 2 places and I get 31%. That's why we're going to round it to 2 decimal places, right? Okay, so let's do blue now. How many blue marbles do I have available?
2.
2. So I'm sorry. I so read green and said blue. Wow. How many green marbles do I have?
7.
Wow. Okay. 7 over 13. And I'm going to do the same thing. I'm going to do 7 divided by 13 in my calculator. And I'm going to get 0.54. And then that's as a decimal. And then as a percent, it's going to be, move my decimal 2 places. It's going to be 54%. And then blue, Ketlin already told me, we've got 2. So that's going to be 2 out of 13. So if I put that as a decimal, I'm going to do 2 divided by 13. Oh, that is 2 divided by 3. 2 divided by 13 is 0.15. And then that's 15%. And I'm just going to say all 3 of these percentages should add up to be 100. I mean, I know I did a little rounding, but it should add up to be 100. Let's see if it does. 15 plus 54 plus 31, 100. Right. Okay.
Dang.
I know, right?
We have a smart teacher, guys. Smart.
Okay, so now we're going to go to kind of another little story problem. And then now it tells me, if it tells me how it wants it, then I don't have to do all 3. But if it doesn't, then I have to do all 3. Does that make sense? So I have to write it as a fraction, a decimal, and a percentage if it doesn't tell me what it wants. So this one says a jar contains 12 caramels, 7 mints, and 16 dark chocolates. What is the probability of selecting a mint expressed as a fraction? So the probability of a mint, that's what we want. Okay, so how many mints do we have?
7.
And my total is going to be 12 plus 7 plus 16. So that's going to equal 7 over, I don't know what that adds up to be. 12 plus, oh, that's not, oh, I hate this calculator. 12 plus 7 plus 16 is 35. Now, I can simplify this fraction. 7 over 35 can be simplified, right? What goes into both 7 and 35?
5.
5 goes into 7? Okay. What goes into 7 and 35? What's the only number that goes into 7? 7. Does 7 go into 35?
No. Yes.
Yes, it does. How many times does 7 go into 7? Oh, I'm going to write this out so you can see, so those of you can understand what we're doing. So I'm going to divide by 7 on the top and divide by 7 on the bottom, and I get 1 over what? How many times does 7 go into 35? 7 times.
It goes 1.
7 times 1 is 35?
No. 7 times 1 is 7.
Okay, so how many times does 7 go into 35?
4.
7 times 4 is 35?
7 times 4 is 28. Oh, so it goes in 5 times.
Thank you. So the probability of drawing a mint is 1/5.
Dang.
1 out of 5.
Can you learn how to...
Multiply.
Yeah, I guess.
That's all division is unmultiplying. Okay. All right, next. The numbers 4 through 14 are placed in a bowl and drawn at random. And then replaced after being drawn. Is it likely or unlikely you will draw a number less than 7? Ooh.
It's unlikely.
Well, let's find out what the probability is first.
Dang, she's like... first.
So, how many numbers are less than 7 between 4 and 14? Does 7 count? If it's less than 7, does 7 count?
No.
Okay, so how many numbers between 4 and 7 then? 4, 5, 6. So there's how many numbers?
3.
3. Great. And how many numbers between 4 and 14? 10. Good. So now I'm going to find the percentage of 3 out of 10. Does anyone know what the percentage of 3 out of 10 is?
Would be...
This one's so easy to figure out.
3.3.
0.3. So what's that as a percentage?
3%.
No, I have to move the decimal. How many places?
2.
2. So it's what? Not 3%. It's, if I move it 2 places, what do I put in that place?
0.
So it's what?
30%.
So this equals 30%. So is it likely that I will draw a number less than 7? No, not likely. Okay? Does that make sense? Okay, awesome. Awesome sauce.
In the deck of 52 playing cards, what is the probability of drawing a spade?
Expressed as a decimal. So how many cards? So we have 52 cards, right? We need to know how many of those cards are spades.
Oh, dang.
How many suits in a deck of cards? How many different suits? 4. So how do I find out how many of those cards are spades?
Divide 4 divided by 52.
Yeah, 52 divided by 4. It should be 13.
Dang.
Good. And then they want it as a decimal, so what am I going to do?
Divide
Divide by what?
by...
What am I dividing?
You're dividing...
It's right here. 13.
divided by 52.
Good. And I get 0.25. It's a fourth of the deck of cards, by the way. I just want to say.
Yeah.
Okay, 0.25. Okay, you have 4 problems to try and figure out. All right, let's go over this. So there's how many letters in Mississippi? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters in the word Mississippi, and 2 of them are P's. And I'm sorry, I should have changed this to probability. What is the probability?
It's 18.18.
Sorry, I should change that. So it's 0.18 or 18%, okay? So the jelly beans in the jar, there's how many total jelly beans in the jar?
They're in the jar.
How many jelly beans? Did you add them all together?
No, I almost did.
12 and 17 and 5 and 13. It's 47 jelly beans. How many of those jelly beans are grape or blueberry?
Grape is 12.
Uh-huh.
And blueberry 17.
So how many is that?
That would be 29.
29 out of 47. So then I'm going to divide, right? I take my calculator, divide, I get 0.62. And they want it as a percent, so that means it's 62% of getting a grape or blueberry flavored. Grape, yuck, blueberry, that could work. That could work. Okay, C, similar thing. We have a jar of marbles. Again, it should say what is the probability. You have a jar of marbles in front of you with the following colors: 7 red, 12 blue, 6 yellow, and 9 white. So how many marbles do I have? How many total marbles do I have? You get your calculator and add them together, you know. Oh, my Lanta.
34.
34 total marbles. This wants to know the probability of selecting a marble that is not blue. So any color but blue. How many marbles are any color but blue?
21.
Nope. 22.
So I missed one.
Yeah, 22. So 9 plus 6 is 15, plus 7 is 22. So that simplifies to 11 out of 17. And then it doesn't say, so I put that as a decimal, which equals 0.65. So that's 65% of drawing something that's not blue. Okay. Yeah, I know.
Still a good percentage.
Yeah. Well, that's because there's only 12 of the 34 are blue, so most of them are not blue. You have the following coins in your pocket: 5 quarters, 6 dimes, 2 nickels, and 12 pennies. What is the probability? Oh, my Lanta. What is the probability as a decimal you will draw a dime? So how many coins do I have? I almost forgot what they were called. 25 coins. And how many of those coins are dimes? 6. And then I put that in my calculator, and I'm going to get 0.24. And that's it.
4%.
No, it doesn't say percent. It just wants, this one just wants it as a decimal. But you could write 24%. Yes. You could write 24%. Yes. So in Delta Math today, I think you have 15 problems. It's just like these, right? You have to add your totals up, decide what they're asking, and it'll either say write it as a fraction. You may have to simplify the fraction, okay? Or as a decimal, or as a percent. And actually, I think I almost only saw decimals or percents, so you wouldn't have to simplify the fraction very much. Okay, does that make sense? So let's go ahead and get that done. Good job.